Hey there, everyone! Welcome back to our channel. I hope you're all doing fantastic today. If you're new here, I'm thrilled to have you join us in exploring some really cool concepts that shape our understanding of the world. Today, we're diving into a fascinating topic in the field of computer science and software engineering, chain abstraction. So, whether you're a seasoned programmer, a curious tech enthusiast, or just someone who stumbled upon this video, there's something here for everyone. Let's unravel the mystery of what chain abstraction is, and more importantly, why it matters. But first, let me ask you this: have you ever been in a situation where you had to break down a complex problem into smaller, manageable parts? Maybe it was a coding project, or even planning your next vacation. Well, that's exactly what chain abstraction helps us do in programming. So, what is chain abstraction? In simple terms, chain abstraction is a design principle that allows developers to create a series of linked operations or functions that can be executed in sequence. This method simplifies complex processes, making it easier to read, maintain, and extend code. Let's break it down a bit. Imagine you have a series of tasks that need to be completed one after the other. In programming, this could look like a series of functions that transform data. With chain abstraction, instead of writing a lengthy, complicated function that does everything, you split it up into smaller, reusable functions that can be chained together. For instance, let's say you're working on a web application that processes user data. You might have functions for validating the data, transforming it, and then saving it to a database. Instead of writing one big function that handles all of these steps, you could create 3 separate functions: validate user data, transform user data, save user data. Using chain abstraction, you could then chain these functions together like this. This approach not only makes the code cleaner but also enables you to easily adjust each step without affecting the others. If you need to change how user data is validated, you only have to modify the validate user data function rather than digging through a long, complex block of code. Now, why is chain abstraction so important? There are several key benefits, and I want to highlight a few of them. When you break code into smaller, manageable pieces, it becomes much easier for anyone reading the code to understand what's happening. Clear, concise code is not just good for you, it's good for your team, too. Anyone who picks up your code later will appreciate the clarity. As software evolves, requirements change. When your code is modular, updating it becomes a breeze. You can easily identify which part of the chain needs to be modified without sifting through a monolithic block of code. With chain abstraction, you can reuse functions across different parts of your application or even in different projects. This leads to less duplication of code, which reduces the likelihood of errors and makes your applications more efficient. Testing individual functions is generally easier than testing one large function. If you need to debug an issue, you can isolate the problem to a specific function in the chain, making it much simpler to identify and fix the bug. Let's look at some real-world applications of chain abstraction. Many modern libraries and frameworks, like jQuery and React, utilize this concept extensively. In jQuery, for example, you can chain methods to manipulate the DOM. Here, each method is applied sequentially to hash my element, demonstrating how chain abstraction can lead to concise and effective code. Furthermore, according to a study by the Software Engineering Institute, teams that adopt modular programming practices, like chain abstraction, report a 30% increase in productivity and a 25% decrease in bugs. That's a significant impact, wouldn't you agree? So, to wrap things up, chain abstraction is a powerful concept in programming that allows us to break down complex tasks into simpler, manageable parts. By doing this, we enhance code readability, maintainability, reusability, and testing efficiency. Next time you're faced with a coding challenge, think about how you can apply chain abstraction to simplify your solution. If you found this video helpful, please give it a thumbs up and don't forget to subscribe for more educational content. Also, feel free to drop your thoughts or questions in the comments below. I'd love to hear how you've used chain abstraction in your own projects. Thanks for watching, and as always, keep coding and keep learning. See you in the next video.